In this video, we're going to do a problem to apply facts about inverse matrices. And the problem says this matrix is invertible. And it's a 4 by 4 matrix A, where the first row is 1, 0, 2, negative 1, 2, 0. The second row is 2, 0, 1, 2. The third row is 7, 4, 3, 5. And the fourth row is negative 1, 0, 2, 1. And the question says, write down the third column of A inverse. And the hint is, you don't need to calculate A inverse. Look carefully at the columns of A. So take a few moments and try to figure it out, and then we'll discuss the answer. Okay, let's go over the answer. So we don't necessarily need to know what A inverse is, but we just need to know what the third column of A inverse is. Well, remember that when you take A and multiply by A inverse, you have to get the identity matrix. So I know that when I take A and I multiply it by A inverse, I have to get the matrix where you have ones on the diagonal and everything else is 0. And it's a helpful fact when you're trying to find the third column of A inverse. So this third column is what we want. Let's call this column 3. It's a helpful fact to remember that when you multiply a matrix by a matrix, you multiply the matrix on the left by the individual columns of the matrix on the right to produce the matrix that is the product. So if you take A and multiply by column 1 of A inverse, you're going to get column 1 of the product. And similarly, if you take column 2 of A inverse and do A times that column, you're going to get the second column of the identity matrix. Right? So A times column 1 of A inverse is the first column of the identity matrix, the 4 by 4 identity matrix, and so on. So A times the third column of A inverse is going to be the third column of the identity matrix. And we're looking for the third column of the identity matrix. So we know that A times that column vector has to equal the third column of the identity matrix, which is 0, 0, 1, 0. So the question is, A times what vector, let's call it x, equals 0, 0, 1, 0. And we're trying to find x. Well, let's take a look at the columns of A. One way to do it is to solve the system of equations where you have ax equals b and b is 0, 0, 1, 0, and then you row reduce. But let's see if we can figure out a faster way of doing it. We know that when you're taking a matrix A and multiplying it by a vector, what you're doing is you're taking linear combinations of the columns of A. So the question is, what linear combination of the columns of A will give you 0, 0, 1, 0? Well, if you look at the matrix A, you can see that the second column is 4 times the vector 0, 0, 1, 0. So that means that you can take 0 of the first column plus 1/4. So 0 times column 1 of A plus 1 times column 2 of A plus 0 times column 3 of A plus 0 times column 4 of A is equal to 0, 0, 1, 0. Right? And so what is x going to be? X is going to be, 1/4. Okay, so what is x is going to be? X is going to be 0, 1/4, 0, 0. That's the third column of A inverse.